class. Now, when we talk about today's class, we will discuss what is thermochemistry. Okay, so I said that this chapter, thermodynamics and thermochemistry, right? So thermodynamics is generally your overall process which discuss the energy change of a system and the surrounding. Okay, right? But thermochemistry specifically deals with chemical reactions. Okay, right? So when we talk about thermochemistry, you can say that thermochemistry tells us about the energy change in a chemical reaction. Okay, okay everyone. So yeah, so before starting this class, we should know what is enthalpy, okay, and what we have studied till last class, right? So let's have a simple review example, review test, okay, or recall test. Let's see who can remember. So question number one. Question number one is a reversible adiabatic process can be defined by the PV relationship. Tell me, what is the PV relationship? Everyone, tell me what is the PV relationship? Yes, very good, Avas, Ronak, Jitendra. No, which is the relation? Which is the relation? A, B, C, D. Which relation? Yes, adiabatic process. Karishma, adiabatic process. Just think about it. We have studied, right? Adiabatic process, okay, is related with PV to power gamma is equal to constant, right? PV to power gamma is equal to constant. The pressure volume is related by this relation for adiabatic process and reversible adiabatic process. Okay, second one, question number two. Just think about it. Question number two. Yes, very good. Very good. It is molar heat capacity, right? It is molar heat capacity. Wait. Yes, it is molar heat capacity. Latent heat is used to change the phase of the system, right? Heat capacity is for overall mass. Okay. For 1 mole by 1 degree centigrade, it is molar heat capacity. Okay. Question number 3. Everyone, question number 3. Tell me. Yes. Very good. Yes. Heat capacity at constant volume, right? NCV delta T. So delta T is 1. So it is CV, right? Okay. And CV is your heat capacity at constant volume. So A. What about fourth? Fourth and fifth? Tell me. Fourth? Okay. Let's see. Many students have different answers. Let's see. What about fifth? So fifth, see, fifth is theory. I have told you, I guess, in different discussion of internal energy, I told you that internal energy is calculated using this bomb calorimeter. Okay, right? Bomb calorimeter. So bomb calorimeter is used for both actually, for internal energy as well as enthalpy, right? So in this case, it should be constant volume, but It is used for constant pressure also in order to find enthalpy. Let's see. Fourth one, in chemistry, what I have told you, Q plus W, right? In chemistry, it is work done on the system. Okay. So please remember this because some of you have said B, Q minus W. So you should be very, you should be very strong. We should have very strong understanding of the concept. Okay. You should be confident. Okay. Okay. Right. So see, so the first topic that we are going to study today is enthalpy, defining enthalpy, right? What is enthalpy and all those things, right? So I hope you have already studied these things. Okay, at least you have watched the videos because we have already studied what is enthalpy, right? We have already studied what is enthalpy. Okay, so now let's think what is enthalpy, right? Tell me, what is enthalpy? In layman term, if I ask you, right? If I ask you, what is enthalpy? Tell me. Tell me. What do you think about enthalpy? Anyone? Measure of energy? Yes. So which kind of energy? What energy? It is the measure of net energy change. Okay, right? It is the measure of net energy change or net energy possessed by the system. Okay, right? So let's see. Let's see what is the basic definition of enthalpy. We have already studied this. Okay, so I hope that you will remember. So when you talk about enthalpy, see, when you talk about enthalpy, it is basically total energy of a thermodynamic system, right everyone? It is total energy of any thermodynamic system. Now, when you talk about total energy, right, when you talk about total energy, so obviously it would be the energy required to create a system, which is your internal energy, plus the energy required for the displacement, right? Means if volume is changing or if pressure is changing, so the molecules are displaced, yes or no, right? So there must be some kind of energy associated with that. Okay, so I can say that the total energy of a system, right, is given by enthalpy, right? It requires two component. First is the energy which creates the system, right, which is its internal energy, right? And second is the amount of energy which is used to move or make space for this system, right, for displacement of the system. So second is the amount of energy required to make space for it, right, by displacing the environment. So when we talk about environment, right, so we can either displace pressure or volume, right? Okay, we can displace a system by either exchanging pressure and volume. So the component of this enthalpy is your internal energy U plus PV. Now this is your absolute equation, but we know that when we talk about change, it is always, when we talk about heat or enthalpy, it is always change. So the change, we have already studied this, right? I'm just revising it. It will be delta U plus delta PV. How many of you remember this? Tell me. How many of you remember this? Yes, I hope all of you remember this. We have studied all those things, right? I'm just revising. Now, the thing is, most of the reactions that we do, okay, most of the reactions that we do are at constant pressure, Okay, so if you see this equation, right, after partial differentiation, we will get this equation, right? P delta V plus V delta P. But since most of the reactions are being done at constant pressure, this term would be zero, okay, at constant pressure. So it will become delta H is equal to delta U plus P delta V, right? And this is equal to Q at constant pressure, okay? And this is also equal to N Cp delta T. That we have already studied. Yes, everyone. I hope all of you remember this. Everyone remember this, right? Since we have already studied enthalpy. Okay, this was the revision that I wanted to do before starting thermochemistry, because you should know what is the enthalpy. Okay, now let's see. Now let's see. We have a reaction A plus B gives C plus D. C plus D. Right? Now, obviously, in order to this reaction to proceed or this reaction to happen, there must be some energy change. Yes or no? There must be some energy change, right? Okay, and each reactant and each product have some energy, right? It should have some energy. Yes. So suppose the energy of H is HA. The energy of B is HB. It can be any energy, by the way. Energy of formation, energy of combustion, anything. It is the name given according to type of reactions. Okay. So for now, I'm just saying it as energy. Okay. I'm just saying it as energy. Right. Now this is your HC and this is your HD. Okay. Right. So these are the respective energies. Okay, right? Respective energies. So if I talk about total energy of a reaction, delta H of a reaction, right? Tell me what it will be, because we have already studied this, right? In entropy. Yes, very good, Wes. So delta H of a reaction is always net sum of heat of product minus net sum of heat of reactant. So let it be, okay, capital R. Got it? So this is the basic definition of heat of reaction. Okay, this is the definition of basic heat of reaction, right? So this is Hc plus Hd minus Ha plus Hb. Yes or no? Right? Yes or no? Okay, right? So this is your enthalpy change of a reaction. This is your enthalpy change of a reaction, right? Now, I told you that this chapter, thermodynamics and thermochemistry, is easy as well as complex, right? If you can just identify the boundary between easy and complex concepts, that will be easy. Okay, so you have to know what is important for you. Okay, right? So I hope all of you understood what is enthalpy, what's the meaning of enthalpy change of a reaction. Okay, now the only thing which I skipped at that time also, okay, when I was teaching internal energy and enthalpy, was how to calculate, right, in real life, how to calculate this internal energy and enthalpy, right? So we know that internal energy or enthalpy, delta U and delta H is actually Q, right? Is actually Q. Now depending on condition, delta U is Q at constant volume and delta H is Q at constant pressure. Okay, so basically we set up a apparatus known as bomb calorimeter. Okay, bomb calorimeter. So in one case we keep volume constant and calculate the net change in energy, heat energy, right? Now at constant volume, that will give you delta U, because no work is being done in that case. Okay, now if you keep pressure constant, means the piston can move, volume can change. Okay, then it will give you delta H. That's why the formula that we've studied was NCV delta T, and for this it is NCP delta T, right? So I'm just revising these things that we have already studied. Okay, so bomb calorimeter you have to study in your school. They'll be teaching these things. Okay, right? It's just apparatus which is used to calculate the value of delta U and delta H. Okay, yes, it is there in videos, LMS videos. That's why it's better you watch it once. Okay, right? Okay. See, I would suggest to watch videos before attending the class. Your concept will be very clear. Okay, the concept would be very clear, right? So Since we have already studied enthalpy, okay, let's have some basic problems, right? Let's solve some basic problems. So tell me, enthalpy is defined by, I just said this, tell me, what is the answer? Enthalpy is defined by which equation? Yes, very good, very good. The answer is A, very good. Second one, if the volume of gas increased by 2 liter at 1 atm and the change in internal energy, okay, is 30 kilojoule. So what is the change in enthalpy? Tell me, what will be the change in enthalpy? It's easy, just calculate. Yes, very good, right? So I guess all of you can calculate this. So you have to use delta H is equal to delta U plus P delta V. Got it, everyone? Right? Got it? Now the only thing that you have to do here is convert the units. Okay? Because internal energy is given in joule. Okay? Right? And the conversion is also given. Right, everyone? So I hope all of you can solve this. Right? So the answer is, what is the answer? The answer is B. Got it, everyone? Tell me, everyone got this? So it will be 30, right? Minus, tell me, got it? Minus 2 into, sorry, 1 into 2. Got it? Right? Okay, very good. Next, tell me, the temperature of 2 mole of water is raised by 2 degrees centigrade. The change in enthalpy is, everyone, tell me, it's a basic formula putting getting. Okay, everyone, tell me. It is basically NCP delta T, right? Just calculate this. Just calculate this. NCP delta T. So the answer should be D, right? NCP delta T. N is 2. 2. CP is 76, right? Into, now, it is raised by 2 degrees centigrade. Means temperature change is 2 Kelvin. Because when you talk about change, so change will be same in degree centigrade and Kelvin. So 2. So the answer should be 304. Got it, everyone? Right? Basic. Okay, it's D. Next, tell me. How many of you remember the second formula? Tell me. Second formula, right? If pressure and volume is not given, right? Then which formula we have to use? How many of you remember this formula? Delta U plus delta NGRT is equal to delta H. Tell me, how many of you remember this formula? Raise your hand. If pressure and volume is not given, if changes in pressure and volume is not given, so can we use this formula? We have already discussed how we got this formula and all those things. Raise your hand if you remember this. Just raise your hand. Okay, everyone? Yes, very good. So tell me, what will be the answer of this problem? Tell me, what will be the answer of this problem? Okay, everyone got your answer, right? So see, what is delta Ng here? Tell me, what is delta Ng? It will be positive or negative? Delta Ng is positive or negative? Yes, very good. It is negative. So delta H is equal to delta U minus 2RT. Got it, everyone? So yes, the answer should be B. Got it? Okay, next problem. Enthalpy is, tell me, state function, path function, or cannot say? Tell me, what is enthalpy? Okay, Nisha, Karishma. Yes, Riya. Yes, Malik. Very good. Srihari, very good. Right? So we studied that enthalpy is your state function. Very good. Very good, everyone. So you remember this concept. Next, just see this. Which of the following statements are correct? Okay. When a gas expands, energy is released, hence work is negative, right? And work is done by the system. That's your first statement. The second statement is enthalpy change for a system is equal to heat absorbed or evolved at constant pressure. That's your statement 2, right? Then we have statement 3, which is a reaction, and delta Ng is equal to 0. Okay. And statement 4, when system returns to its original state, some change in a state function occurs. Okay. Now tell me, which of these statements are correct? Which of these statements are correct? Think, everyone. Okay. So many of you are saying B. Okay, I'm getting all the answers, right? So let's see the answer first. Then you might think again. Okay. The answer is B. The answer is B, right? So most of you were right. Okay. Now see option number or the statement number 3 and 4. Now delta Ng is 0, right? Now if delta Ng is 0, it has anything to do with work done? Tell me. If delta Ng is 0, right, it doesn't mean that P delta V will be 0. Yes, it doesn't mean that P delta V will be 0. Okay, work will be done, right? So I cannot say that if delta Ng is 0, then no work is done. Yes, right? Okay. Now, fourth one. We know that if system returns to its original state, okay, right? State function will also be same. Yes or no? Right? That's the basic definition of state function. Yes or no? Right? So if you know the definition of a basic concept of state function, so you should be able to solve or Actually, think about statement number 4. Okay? Okay then. Let's see next problem. Okay, so next we have concept now, right? So I guess all of you have studied what is enthalpy, right? What is enthalpy? So what we will be doing now is different type of enthalpies, right? Different type of enthalpies. Okay, everyone? Tell me. Ready? Now, just think about this. Enthalpy is same. There's a basic definition of enthalpy, right? So your question should be, why there will be different type of enthalpies? Tell me. Can anyone tell me why there will be different type of enthalpies? Tell me first. Why there will be different type of enthalpies? Or let me ask you another question. Is all the reaction are of same type? Is all the reaction are of same type? Right? Let's see. I will give you these reactions. Right? I will give you these reactions. Now tell me, all the three reactions are of same type? All the three reactions are of same type? Yes or no? All the three reactions are of same type? No, right? Okay. So what can you say about first reaction? What can you say about first reaction? What type of reaction is first reaction? Combination, okay? Or it's a formation of H2O, right? It is a formation of H2O, right? So you can say that it is a reaction for formation of H2O, of H2O. Why I am saying formation? Because both hydrogen and oxygen are in their which state? Natural state, right? Got it? Okay. What about second reaction? Tell me, what is the second reaction? Yes, very good. So second reaction is your combustion reaction. Combustion reaction. What about third reaction? What is your third reaction? Yes, very good. So third reaction is neutralization reaction. Neutralization reaction. Agree? Everyone? Everyone is getting this? Yes, everyone? Everyone is getting this? Right? Now, if I want to find, just think about this, delta H of reaction, delta H of reaction, in case of first one, right? What this will be called as? Will it be called as heat of formation? Tell me. Can we call it as heat of formation? Yes? Okay. For second equation, can we call it as heat of combustion? Right? And for third reaction, sorry, third, it's not fourth. Can we call it as heat of neutralization? Right? So I'm getting this point that we have different type of heat of reaction depending on the type of reactions. Right? Depending on type of reactions. So obviously there'll be different type of reactions. So we have to study all those different type of reactions, and the heat associated with that will be called as different type of heat of reaction. Okay, everyone? Got it? So I hope all of you got the idea that ultimately it is same thing. Only name is changed. Okay? Got it, everyone? Okay. Now, before starting this, before starting the different type of enthalpies, right? Let's have one theory. It is called as Kirchhoff's equation. Okay. Or Hess law. Forget about Kirchhoff's equation. We'll just study Hess law. Hess law. Okay. Now, what is Hess law? Hess, H-E-S-S, Hess law. So suppose I'm having a reaction where A gives B. Just think about this. A gives B and delta H1 is the energy associated with this reaction. Then we have B gives C and the energy associated with this is delta H2. So what will be the total action? It will be A gives C, yes or no? Tell me, yes or no? Yes? So can I say that delta H, this total, is delta H1 plus delta H2? Yes or no? Yes or no? Right? Makes sense, no? Makes sense? Right? So this is your Hess law, as simple as that. I'm trying to explain everything in a very simple way, right? Because when you try solving problems, you will know how to use these equations. Okay? Right, everyone? Anyone have any doubt in this? Okay? Now, if the equation would have been this, just think about this. If the equation would have been this, C gives B, right? And we have delta H2. Then what is delta H total? Tell me, in this case, what is delta H total? Yes, very good. Right? Since the reaction is opposite, it would be minus delta H2. Got it, everyone? Right? Because energy required from B to C will be negative of delta H2. Okay? Okay, everyone? Right? Okay, everyone. I hope all of you understood what is your Hess law. Right? Okay. Now let's see different type of reactions. Karishma, I was writing. Okay, I was writing. You missed it something, I guess. Okay. Right? Okay, I will write now. So the first. So just give the heading types of okay, right? Different type of enthalpy of reaction, right? Or types of enthalpies of reaction. Enthalpy. Yeah. Enthalpies of reaction. Types of enthalpies of reaction. Right? Okay. Okay, everyone. So you have to remember the definition. That's it. As simple as that. Okay. In this case, you just have to remember the definition. So the first that we have to study is standard enthalpy of formation. Standard enthalpy of formation. Enthalpy of formation. Okay. Got it, everyone? Now just think about this. What do you mean by standard enthalpy of formation? Tell me. So can I say that it is the energy or enthalpy, right? Or energy change. Okay, energy change, energy change, change for the formation of what? Tell me. 1 mole, 1 mole, okay, of a compound, 1 mole of a compound, right? Right? Is this totally diffusion? No, right? Because we are creating this compound from what? From some other compounds, right? So can we say that it is a heat of formation? No, right? Yes, Oves. Yes, Abhiram. Right? So there's second part also. Okay. From its elements in their most stable state. Their stable state. Stable state. Okay. For example, H2, O2, these all are the elementary states. Okay. H2 will exist as H2, hydrogen will exist as H2. No, Samarth. This is different topic, na? Heslock finished. We will study it again. Okay. After we'll study all the type of enthalpy of reaction, then we will use it. Okay. I just gave you brief about Hess law because we might be using, okay, in the problems, right? Okay, everyone. So tell me, if H2 is the elemental state, it's the normal natural state. So what will be delta H of H2? Tell me, what will be the heat of formation of H2 if it's natural state? Yes, very good. It should be 0. Yes or no? Because it's natural state. It naturally exists in that state. Yes? In the same way, for O2, delta H of O2 should be 0. Yes or no? Okay, very good. Now, there are some type of elementary state that you have to remember. So H2 and O2 I have told you. Now for carbon, it is graphite form. Okay. For carbon, it is graphite form. For sulfur, it is rhombic form. Okay, so these are its natural state. Okay. There are 110 plus elements now. So it will be given in the problem. Okay, it will be given in the problem. So let's see one example. Let's see one example. Now you have to remember the formation reaction is very specific. For example, H2 gas. Wait. H2 gas plus half O2 gas. Okay, will form what? H2O. But gas or liquid? Tell me, gas or liquid? It will be liquid. Got it? Yes. So it will be liquid. So you might be thinking, sir, हमें को कैसे पता? How do we know that? So we have to remember after solving problems, right? Like I've told you that this is the reaction You have to remember that this is a reaction. Okay. Now, if I have given H2O gas, suppose I have given H2O gas, right? Okay, H2O gas. So technically, this delta H, okay, is not equal to delta H formation of H2O. Okay, right? Because I told you the most stable state, normal stable state, right? For H2O, the normal stable state is liquid. So this reaction will be sum of two reactions. So the first reaction would be this that I said you, okay, H2O liquid, then this H2O liquid is converted into H2O gas. Okay, so this delta H is given. So this is the delta H total. This is delta H formation, and this is delta H vaporization. We will study that also. If you add these two, then you will get delta HT total, right? Got it? So see how we used Hess law. That's why I taught you Hess law before. Okay, so you have to be very specific about the reactions. Yes, OS. Delta HF plus delta vaporization. Got it? Got it, everyone? Okay. So can you tell me what will be the reaction for the formation of CH4? Tell me. What will be the reaction for the formation of CH4? Tell me, anyone? If I have to find the heat of formation of CH4, so what would be the reaction? It would be C, graphite. If I'm writing C, it is graphite, but it exists in solid state, right? Plus, yes, very good. 2H2, but this will exist in gaseous state, and it will give me what? CH4, and this CH4 exists in gaseous state, right? So this is your reaction for formation of CH4. Okay, right, everyone? Tell me. In the same way, I can say, I can form another reaction, plus or 2C plus 3H2 gas plus half O2 gas. We will get what? Tell me what we will get. Yes or no? C2H5OH. Now this is your alcohol, right? This is your alcohol. Yes, very good. And what will be the state of this? Liquid, right? So this is the heat of formation of alcohol, right? C2H5OH. Okay, this is the reaction for, or the heat exchange of this reaction with the heat of formation of what? CH4. Got it? Yes or no? Tell me. Got it? Okay. Right, everyone? Okay. Just answer me one problem. Okay, just answer. If you understood this concept, just tell me what will be the heat of formation of HBr, right? I have given you this reaction, H2 plus Br2. Okay, liquid. Now this is the natural state of Br, right? Bromine exists in liquid state now. So we will get 2HBr. Now this delta H of a reaction is equal to minus 72.8 kilojoule per mole. Okay, right? Okay, everyone. Then tell me, what will be the heat of formation of HBr? Tell me, what will be the heat of formation of HBr? Yes, yes, Subhas, right? Yes, Jitendra, somewhere you're wrong. See, right? As I told you, basic definition. If you see the definition, just see the definition, right? 1 mole of compound, right? You have to form 1 mole of compound. But here, how many moles of HBr is formed? 2, right? Okay, so this is total heat of reaction. For heat of formation of HBr, it should be 1 mole, right? 1 mole, right? Gives HBr, right? So it will be the half of this enthalpy. So delta HF will be, okay, delta HF will be half of delta H of reaction. Got it, everyone? So this will be minus 72.8 by 2, which is minus 36.4 kilojoule per mole. Got it, everyone? Got it? So this is one thing that you have to remember while solving the problems. Okay? Right, everyone? Tell me. Right, everyone? Understood? Tell me. Everyone got this? Okay, let's solve one more problem. Let's solve one more problem. Suppose I have given you this reaction. CaCO3, okay, CaCO3 solid plus CaO. Now this is also solid, right? Sorry, not plus. CaCO3 will give you CaO. Give you CaO plus CO2 to gas. Okay, right? Question is find delta H of a reaction if I have given you delta H formation of CaO, okay, is equal to minus 635.1 kilojoule per mole. Okay, delta H formation of CaCO3 is given as minus 1206.9 kilojoule per mole, and delta H formation of CO2 is given as minus 393.5 kilojoule per mole, right? Can you find delta H? Tell me, can you find delta H? Everyone, can you try? Try, everyone. Everyone, please try and let me know. Let me know. You just have to find delta H of a reaction. Okay, so we have to use the first concept that we studied, that delta H of reaction is sum of delta H of product minus sum of delta H of reactant, right? Just calculate, everyone, calculate. So I can say that delta H of reaction is equal to, right? Now it will be delta H F of CaO plus delta HF of CO2, right? Got it? Minus delta HF of CaCO3. Yes or no? Tell me, step by step. Yes or no? Right? Yes? Okay, Karishma. Okay, so let's see. Just put the value. So delta H of CaO, delta H of CaO. What is given? I have given it as 635.1. And this is your 1 mole. 1, right? If it would have been 2, then you have to multiply by 2. Right? Right, everyone? Okay, because this is delta H of is for 1 mole. That is something that you have to remember. Now delta H of CO2, right, is minus 393.5. Okay, and minus of minus 1200, tell me, 1206.9, right? So obviously if we calculate, it will be minus minus plus, so 1206.9 and this minus, you can just add these two, so 0.682 and tell me 10. Got it? If you subtract these two, you should get something like 178.3. Okay, kilojoule per mole. Got it, everyone? Tell me, got it? Now you know how to use these equations. Yes? Okay, right? Okay, 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 everyone, right? Now we know that this delta H of reaction, is greater than 0, positive. Then energy is released or energy is absorbed? Tell me, we have already studied this. Then energy is absorbed or energy is released? Absorbed, right? Okay, so I can say that energy is absorbed. Okay, then this reaction in which energy is absorbed is called as endothermic reaction. Endothermic reaction. And in the case where delta H is less than 0, it means the energy is released. And they are called as exothermic reaction. Okay, everyone? Got it? Tell me, I hope all of you understood what is enthalpy of formation. Yes or no? Yes or no? Okay, very good. Let's see another enthalpies. Second, just have to understand the definition. So study the definition of all. Okay. Am I audible, everyone? I guess it should be fine now. Okay. The second is enthalpy of combustion. Enthalpy of combustion. So tell me, what would be the enthalpy of combustion? What would be the basic definition of enthalpy of combustion? Tell me, right? It will be the what? Tell me. Same enthalpy change. Yes, enthalpy change. Enthalpy change when 1 mole of substance or 1 mole of any compound combined with what? Tell me. Combined with required amount of oxygen. Required amount of oxygen. Okay, right? To give stable product. Okay. Got it, everyone? Tell me, everyone got this? Yes or no? Right? So let's see one example. C2H6 in gaseous form plus now O2, it will give what? 2 CO2, right? Okay, plus 3/2 H2O. Okay, and this would be what? This would be 7/2 O2. Okay, right? So if you can just multiply this by 2, so we can have this equation. 2C2H6 gas plus 7 CO2. Sorry, my voice breaking. Everyone, is it fine now? I have changed the network. I think it is fine now. Okay. Got it, everyone? Got this? Tell me. Got this? Okay. Okay, everyone. So tell me, for this reaction, the second reaction, if delta H of reaction is minus 745.6 kilocalorie, right? So what is delta H of combustion? Delta H of combustion for C2H4, sorry, C2H6. Tell me, what is delta H combustion for C2H6? Tell me. Anyone? Yes, very good. Right? Because we have 2 moles. Okay, and according to definition, it should be 1 mole. So the answer is 372.8 kilocalorie. Okay, everyone, tell me, got it? I hope all of you got the basic idea of enthalpy of combustion. Yes? Okay, very good. Now in this, we have to study one more term, which is known as calorific value. Calorific value. Okay, so I hope all of you have studied this in junior classes. Okay. Okay, Soumya. Just ask her to watch the videos, okay? So calorific value is basically heat of combustion of fuel, heat of combustion, right? In chemistry, divided by, now this is for 1 mole, right? So it would be mass of 1 mole of substance or molecular weight of substance, molar weight of substance. Got it? So this is your atomic or molecular weight. Molecular weight. Got it? Tell me. So this is your basic definition. Okay. Okay. Got it? So this is your second type of enthalpy. A third, you just have to remember the definitions because the concept is same, product minus reactant, except for bond energy. Every energy of reaction is always product minus reactant. So next is enthalpy change during phase transformation. Enthalpy change during phase transformation. During phase transformation. Now, do we even say the definition of this one? Tell me. Do we say, right? I hope all of you know what is the meaning of phase transformation. Yes, right? Do I write to definition? Do I need to write the definition? Tell me. Do I need to write the definition? Or you can just write it. Okay. So you can say that it is the amount of energy change when 1 mole of substance changes its phase. Yes or no? Tell me, yes or no? For example, right? So what is this? This is delta H of vaporization, right? Delta H vaporization. Got it? In the same way, if it is converting from solid to liquid, it will be delta H fusion. Okay? So I hope all of you remember this. Just definition. 1 mole. This is also for 1 mole, right? Fourth one. Heat of neutralization. Heat of neutralization. This is very important. Ionization. Okay. Now, when you talk about heat of neutralization, so you know that it is this reaction. Acid plus base gives salt plus water. Salt plus water. Yes or no? Tell me. Yes or no? Right? Right, everyone? Anyone have any issue in this? Tell me. Anyone have any issue in this? No? But the actual heat of neutralization, right, would be the energy change when 1 mole of H plus, when 1 mole of H plus combine with 1 mole of OH minus, 1 mole of OH minus, to form H2O. Okay, that is the basic definition. Got it? That is the basic definition. So you can say that it is H plus OH minus gives H2O, right? And again liquid. And in this case, it is delta H minus 57.1 kilojoule. Okay? Got it, everyone? Tell me. Now, do you think this H is same as heat of formation of H2O? Tell me. It is not same as heat of formation of H2O. Okay. It is not same as heat of formation of H2O. Right? So you are saying, right? Or I'm saying that heat of neutralization when H plus combined with OH minus is always this delta H is equal to minus 57.1 kilojoule. Right? I'm saying this. Okay. So does that mean that heat of neutralization of any reaction or heat of neutralization of any acid or base will always be minus 57.1? Tell me. Will it always be minus 57.1? 1 mole OS per mole I'm saying, okay? Per mole, this is per mole, okay? My question is, will heat of neutralization for any acid base pair, acid base pair, right? Case A, always equal to 1, equal to minus 57.1 kilojoule. B, always less than or equal to minus 57.1 kilojoule, okay? Or C, always greater than equal to minus 57.1 kilojoule. Tell me, A, B or C? एक्सेप्शंस यहाँ होते हैं ऑब्वियसली, तो यहाँ पे मैं डिस्क्लेमर लिख दे रहा हूँ, with few exceptions. केमिस्ट्री है, ठीक है? टेल मी. Now, if you actually understand this reaction, okay, you would be able to answer. Let's see one problem. NaOH plus HCl, right, will give me NaCl plus H2O. Got it? Yes or no? Right, this is a neutralization reaction. Okay, but I can break this down in this reaction. NaOH gives Na plus plus OH minus, and HCl gives H plus plus OH minus, H plus plus Cl minus. And if you add these two, you're actually adding this. Yes or no? Tell me. Yes or no? Right? Now tell me. I just said that this reaction have delta H is equal to minus 57.1 kilojoule, right? So is this reaction and this reaction are same? Tell me. This is reaction A and this is reaction B. Are they same? Think about this. Are they same? Is reaction A or reaction B are same or different? Are they same or different? Everyone think? They're not same actually. That's the concept. Because see, this NaOH is breaking down into ions. So it might have some heat of dissociation, right? Delta H dissociation. Okay, in the same way, this should also have some, right? Okay, but in this particular example, NaOH or HCl, both are strong acid and strong base. Strong base and strong acid. Strong acid, right? So what's the definition of strong acid and strong base? Tell me, what is this definition of strong acid and strong base? Anyone? Tell me, definition of strong acid and strong base, which dissociates completely on its own. Yes or no? Yes or no? Right? Strong acid and strong base are those acid and bases which will dissociate completely on its own. Yes? Yes. Right? So I can say that for strong acid and strong base, delta H dissociation is 0. Yes or no? It is 0. Yes? Tell me. Yes? Okay? Got it? So if delta H dissociation is 0, right? Then you can say that this delta H of a reaction is equal to this one. Right, everyone? But take this reaction, NH4OH plus HCl. Just think about this. Gives NH4Cl plus H2O. So you have to find delta H of a reaction. Just think about this. So I can say that this reaction can be written like this. NH4OH gives NH4 plus OH minus. Yes or no? Tell me yes or no. But is this strong base? Is this strong base? No, right? So there must be some energy, right? There must be some energy of neutralization, dissociation. Okay, there must be some, right? So let us rewrite it as X. Okay, now since it is okay, can you hear me, everyone? Yes, you can hear me, right? Okay, and for HCl, it will be 0 only, H plus plus Cl minus, right? Because it is strong. So delta H dissociation is equal to 0, right? See, I have written plus X because energy is required. So what do you think? What will be delta H of overall reaction, right? Delta H of overall reaction. So overall reaction would be this, NH4OH plus, sorry, NH4 plus OH minus plus H plus Cl minus gives NH4Cl plus H2O, right? Right, everyone? So we have how many reactions here? 3 reactions, right? First is this reaction, NH4 plus OH minus is being broken down. Then H plus and OH minus is combined to form H2O, right? You have to find this delta H, this delta H. Okay, got it, right? Yes or no? Yes or no? So what you will do? You will, and for this reaction, we know that delta H is equal to minus 57.1 kilojoule. Right, everyone? So tell me, can I say that delta H of whole reaction, is equal to X plus 0 plus this delta H of neutralization? Yes or no? Tell me. Yes or no? Yes. Tell me. Agree? Everyone is agreeing, right? According to Hess law. According to Hess law, है ना? If you add these three, you will get this equation, है ना? If you add equation number A, equation number B, and equation number C, right? You will get this equation using Hess law. Got it, everyone? Yes or no? Tell me, yes or no? Okay? Okay, everyone. So tell me. Now in this case, this delta H of reaction is minus 57.1 plus X. So tell me, this is less than minus 57.1 or greater than minus 57.1? Talk about the value. Because negative sign is just the symbolization of it is released or it is absorbed, as simple as that, right? So I can say that, okay, that less energy would be released. Okay, less energy would be released, right? Okay, so I can say that heat of neutralization of overall reaction is equal to heat of ionization of acid or base plus minus 57.1 kilojoule. Got it, everyone? Tell me. Yes? So I can say that heat of neutralization of any acid and base, base is equal to minus 57.1 plus delta H ionization. Yes or no? Tell me, yes or no? सबको समझ में आ रहा है? साम्या, मानसी, सुमैया, सबको समझ में आ रहा है? Yes or no? Right? As simple as that. बस तुमको याद रखना है. ठीक है? मैंने step by step समझाया. That's why I taught you Hess law before. Okay? Got it, everyone? Tell me. Got this? सबको अच्छे समझ में आ गया? What is heat of neutralization? Yes? Okay. Right? So we will have one more class. वहां पे खत्म हो जाएगा ये. ठीक है? कुछ और definitions हैं. So I would request you to please watch 6.3 and 6.4. ठीक है? Wednesday class से पहले 6.3, 6.4 एक बार अच्छे से देख लोगे तो पूरा concept clear हो जाएगा. ठीक है, everyone? Tell me. सबको समझ में आया? Right? और just solve one problem. एक प्रॉब्लम सॉल्व करो. ठीक है, मैं बता रहा हूं. लास्ट प्रॉब्लम. सो आई हैव गिवन यू delta H neutralization of acetic acid, which is CH3COOH by NaOH, okay, is equal to minus 50.6. ठीक है, minus 50.6 kilojoule per mole. Okay, this is given. You have to find delta H ionization of CH3COOH, right? Okay. Now what is given? Now in this case, I have given you that delta H neutralization of strong acid is minus 56 kilojoule per mole. Okay, instead of 57, I have given you minus 56 kilojoule. Okay? If it is not given, then you can just take it as minus 57. Okay? Yes. I hope everyone is able to solve this, right? Yes, very good, everyone. So you can say that delta H neutralization is equal to minus 56, which is given, plus delta H ionization according to formula, right? है ना? Chalo, very good. So delta H ionization is equal to delta H neutralization is minus 50.6, and this will go this side. It will be plus 56. Okay, so it is 5.4 kilojoule per mole. If you have taken 57.1, so it would be 6.5. Okay. Yes. I hope all of you understood heat of neutralization. Just raise your hand. Everyone got this? Okay. Okay, very good, everyone. Meet, just send me the those students who are present. No, sorry, send me those who are absent, okay? Okay. Bye, everyone. Sneha already sent me, I guess. Okay, bye, everyone.